Hi all, welcome to another video of linear control systems, and today we are going to do a problem based on polar plot. So here the problem is the open loop transfer function of a unity feedback system is given by g of s is equal to 1 plus 0.2s into 1 plus 0.025s divided by s cube into 1 plus 0.005s into 1 plus 0.001s. Sketch the polar plot and determine the phase margin. So this is the question, and by observing the function given, first we can predetermine the approximate shape of the polar graph. But here there are zeros here. There are 5 poles and 2 zeros are here. So based on that, we can say uh, it is a type 3 system. Okay, type 3 system. That is, for a type 3 system, we know that the polar plot will start from this side. Okay, from this side, and here, instead of the order, we have to take the p minus z value. That is, for finding the end of the polar plot, we have to take the p minus z value. That is, for functions having zeros, we have to use this equation p minus z. So here the p minus z is that is 5 minus 2, so we will get as 3. So the p minus z values is 3. Okay, so it is a type 3 p minus z 3 system. Okay, so for a type 3 system, we know that the polar plot will start from this side, and for a p minus z value, it will end at this quadrant, that is in the second quadrant at origin. Okay, so the approximate graph, okay, the approximate polar graph will be will be like this. Okay, we know that for a type 1 type 0 system, it will start from here. For type 1 system, it will start from here. Type 2 start from here. Type 3 start from here. And for order 1, it will end here. Order 2 and here. Order 3 and here. But here the zeros are there, so instead of order, we are taking p minus z. That is the only difference. Okay, so this is the approximate graph we should obtain. And uh, as the same, we are using the same procedure. That is, first we have to find the sinusoidal transfer function g of j omega by substituting s equal to j omega, and after that we have to find the magnitude value, that is mod g of j omega. So here the magnitude value is root of 1 plus 0.2 omega square, that is root of 1 plus 0.2 omega square into root of 1 plus 0.025 omega square divided by omega cube into root of 1 plus 0.005 omega square into root of 1 plus 0.001 omega square. Okay, and after that we have to find the angle g of j omega. That is, using the a plus jb equation, we know that angle is tan inverse b by a, tan inverse b by a. Okay, so first, this is a first order system. So the phase angle is tan inverse 0.2 omega by 1, that is tan inverse 0.2 omega plus tan inverse 0.025 omega. Then other terms are in the denominator, so we are using negative sign. So minus omega cube is phase angle of omega cube is 270, and the phase angle of this one is minus tan inverse 0.005 omega and minus tan inverse 0.001 omega. Okay, so this is the magnitude and phase angle. Then we have to choose different values of omega and find the corresponding magnitude and phase angle. So that's all. So these are the different values of omega, and we have found the values of magnitude and phase angle by substituting these values in our equation, this equation and this one. And after that, for plotting the polar plot in our normal graph sheet, we have to convert this polar coordinates into rectangular coordinate using our calculator. Okay, and after that we have drawn this graph. We know that the graph is entirely located on the second quadrant only. Okay, so this is the positive imaginary axis, and this is the negative real axis. Okay, and by plotting the polar graph, by plotting each of the point, by combining them, we are obtaining a structure like this, shape like this. Okay, and for finding the phase margin, we have to draw a unity circle. Okay, and we have to draw a line from the origin to that crossing point of unity circle with our polar graph. So this is the line, and after we have to measure the angle from the positive real axis, in the clockwise direction to this line. Okay, so here we are obtaining the phase angle 5GC. Okay, 5GC as minus 257. minus 257, that is from positive real axis to this line in the clockwise direction. And phase margin is gamma is equal to 180 plus 5 GC, that is 180 minus 257, that is minus 77 degree. This is the phase margin. And for this system, the gain margin will not be the, that is because the polar graph is not crossing the negative real axis. Okay, this is the negative real axis. If the polar graph is crossing the negative real axis, then only we can say the correct gain margin, but here it is not crossing the negative real axis. Okay, so that's why in the question itself they are asked only for the phase margin. So here the phase margin is minus 77 degree. So I hope all of you understand the problem well. So thank you.